Okay, so in the earlier I did a video where I explained this LED countdown. Turn off the light so you can see it a little bit better. So there's this counter that displays a digital number. I used the same circuit that I had built for this to just do a simple countdown, and now I'm applying it to use in the second important part of our laser tag system, which is the gun. So in this circuit, the only thing I did, actually, since I'm going to use a camera, I can go ahead and swap out that green LED for an IR emitter because it's going to actually show up on the camera. For the purposes of building this, however, I did just use a green LED. But this is an IR emitting LED, and what I have is a fire button here. Allows me to hold down the button, and when it gets to a certain threshold, this counter is going to be the ammo, and that's going to go down. And it also will make kind of a beeping noise, so you can see that the IR light goes on and the counter goes down. When we run out of ammo, we get a different tone. And then up here I have a recharge button, which recharges our ammo. So unlike the death function of the receiver, you can recharge no matter what state the ammo's in. The only thing that's written in there is that you cannot hold down both buttons at the same time, so no cheating. Okay, so now I'm going to go ahead and draw the circuit diagram for this board, and then go over the program, and then what I'll do is then rebuild this guy for you to see after we have all those done. Okay, so I'm actually just starting from the wiring diagram of the of that counter pin that we see. So I'm just gonna add on to it over here. So what I have, so we do have a bunch of things in common with ground here. So I'm gonna draw that out that way. So I also have, oops, an R1 resistor there, and that one goes to an LED, and this is the IR emitting LED, and that one is pin 13. Okay, then we have our buttons, which are acting as a switch. That's going to plus 5 volts. That's R2, and that goes to ground. And the first one, so we have those going to 12. And then we have one, we'll just, yeah, this one, hop over there, goes to 5 volts. That's R2. And goes to pin 11. So those are 2 buttons, that's our LED. Oh, and we do also have a speaker pin. That's a piezo. And this one is going to pin 9 right now. And that's everything. That's yeah, everything that we have for the circuit. It's a bit simpler than the receiver circuit. So next will be the next is going to be the program. Okay, here is the program. So first off, we define what everything is. Says integer, I have the IR pin, that's the LEDs, that's the IR emitter. The LED pins that go to this counter. The fire button is number 12, the recharge button is number 11, and the speaker is going to 9. This part of the code I covered in the video about making a LED countdown. And then I like the way that we have kind of a semi-continuous way that we hold down the trigger and hold down the receiver for the other system. So we have the same sort of thing here. So just like in the receiver, the main idea was that you have hit points. Here the main idea is you have ammo, and the ammo is topped out at 9 because I only have one of these LED counters. Okay, then ammo value. This value will increase as you're holding down the fire button. When it reaches ammo thresh value, then that will decrease your ammo by 1. We also conversely have a recharge value, and that's when you're holding down the recharge button, and when it reaches this recharge threshold, that's when it restores the ammo by 1. So those are numbers that you can easily adjust to adjust the difficulty level for, say, different age kids. This is a function to have something called numbers right to read out numbers, and the numbers are defined here. So that's covered in the other video with the LED counter. This is another function that's a recharge function. So later on in the loop, we just call on, do the recharge function. So this means that, the recharge function is to have this recharge value increased by 1. If the recharge value reaches the threshold and the ammunition is less than 9, then it increases the ammo by 1 and also goes back to 0. So it loops around. Once it gets to 3,000, it goes back to 0. Just like the hit points and health points in the receiver. This is the initialization setup code here. I didn't want to type out all the pins, so I have it just go from an integer 0 to less than 8 to start each one of those, marking each one of those pins as an output. So that does 2 through 8. Marking them as out points for the LED, the segments on that LED button. This is the output for the IR pin. I suppose I could have written that in here too, but yeah. And then we have the fire button as an input and the recharge button as an input. This serial begin is just so that we can, when Jonathan was writing the program, so he could print stuff out and see what was happening. And then we have numbers right here. So numbers right to ammo. That means as soon as we start the program, it automatically sets that LED thing to 9. And then the speaker pin is an output. So then in our loop, what it starts with is first, if the fire button equals 0, which means it's being held down, and the ammo equals 0, it does that sort of high-pitched sound. And this is just something for the particular speaker we're using to get it to make a higher-pitched sound. Then if the digital read fire button is pushed down and the ammo is greater than 0, and the recharge button is not being pressed, then we have the IR pin turn on. So now it's firing the gun. And the ammo value is being increased by 1. And also the speaker goes to start making a noise. We experimented with making it make a different tone, but that just delayed the program so much that it didn't seem worth it. So those are commented out. Then if the ammo value reaches the ammo threshold, it goes back to 0. Okay, so and once the ammo threshold is reached, this ammo value counter loops back to 0, and we decrease our ammo by 1. And then when we come back up to the beginning of the loop, you see this is outside the if statement. So that makes this, if we write a 9, it will write an 8. And the way that it knows to go from 9 to 8 is written in this numbers right function. So else, so if neither one of these if conditions are met, then the digital write IR pin is set to off and the speaker pin set to off. So that means that the LED turns off and the speaker turns off. Another condition is if the recharge button is pushed down and the fire button is not pushed down, then I have a different tone of the speaker pin, and then it calls on that recharge function, which is up here, and the recharge function will start a counter increasing the recharge value, and once the recharge value reaches the recharge threshold and the ammo is less than 9, then the ammo increases by 1, and also the recharge value goes back to 0. So it always loops around to what you set the maximum as. If none of these conditions are met, then else the recharge value goes to 0. And that's it. That's the entire circuit for our IR gun. So now I'm going to go ahead and take it apart and put it back together again, looking at the diagram. Okay, here's the blank breadboard, and I'm ready to come back in and rebuild this guy. So I'm going to start, I guess maybe this time I'll put this guy up here. Alright, and then just working off of this diagram I have, I'm going to be putting pin 1 to 2, and then I want 6. Actually, let's use longer wires here like I did before. Not sure if those are the right holes there. Let's see, so that's 0, 1, 2, 3. And then this guy is 2. Let's stick these guys up there. Now we'll use some shorter wires. So we have pin 8. Then pin 9. We don't need 10 or 13, but we do want to have 14. Okay. And then let's grab a 560 ohm. That's going to go in 4. And it's going to go to our ground. Can get one of the longer wires out, connecting the grounds to ground. And then just trying to, sort of get these wires out of the way. And then that's gonna go to our ground. And I already got the program loaded up in there, so that's kind of some nice instant gratification that we see that that part worked. Alright, so then I'm gonna go into the IR. I'm gonna put it here. And that one. Trying to put these so it can be a clear path. Okay, and let's grab a longer wire. It seems like when I want them, I can never find the short wires. When I want the longer wires, I can never find the longer wires. Alright, the positive end of that is going to go to pin 13. Okay. Next, let's go ahead and do that speaker. Can use some short wires for this one. We're gonna have one of these guys go to ground. The other one is going to go to pin 9. Okay. And next will be our buttons, which I'm going to try to put in a way that we can actually get to them in a fairly decent manner. And I have the 10 kilo ohm resistor here. Each one of them needs one of those. The other end goes to the ground rail. Okay. And then these are going to go to 12 and 11. Oh, just wondering, so why is it starting to make a noise there? Probably because right now there's no power. There we go. Alright, so let's recharge. And then let's fire. Let me turn off the light so you can see that that LED is firing. Yeah. So the trick with working with these IR LEDs is when you're working with it, you probably want to just put, you can easily just pop that out, stick a red or green one in so you can actually see the damn thing. There we go, so you can see that it's firing. You can see the IR through the camera, But funny thing about IR is that you can't see it unless you're looking through the camera. But it's a nice trick that you can actually just use a camera to see the IR. And there we go. There is our laser tag gun with ammo and reloading capability.